Now, let's try to look into now the problem that we have. So, we have in here, sketch the parabola represented by the equation y raised to 2 plus 10y minus 4x plus 29 is equal to 0. Notice that when we have this kind of problem, we have to recall the standard equation of the parabola. And so, when you recall the standard equation of the parabola, mind you that the one being raised to the second power is y. Okay? So, what is the standard equation that you're going to recall? Definitely, the equation of the parabola that faces the y-axis. Okay, so what is that? That is the same as y minus k raised to 2. That is 4p multiplied by x minus h. Another one is y minus k raised to 2 is equal to negative 4p. That is x minus h. The point in here is recall the standard equation of the parabola. That is considered to be the horizontal parabola. Okay? Horizontal parabola. Now, what is the use of this one? So, we will be using these things. Okay? So, how's that? Let's get the problem. Okay? It says in there, your equation says that y raised to 2 plus 10y minus 4x plus 29 is equal to 0. How do you do that one? Okay, how will you get a binomial factor? Okay, or binomial factors, or a binomial factor that is raised to the second power. Meaning, you notice this one, dy is at the left side, dx is at the right side. So what will you do? Combine those number with the same variable, y. Combine those number with the same variable, x. Now, if dy is the one being raised to the second power, more or less, that is the one you will be applying the completing of the square. Okay, you follow? So notice that we have now in here y raised to 2 plus 10y. Okay, I will complete this one to be a perfect trinomial square, and so that is added to what? My problem. Okay, what about the other side? Definitely, that is the same as 4x minus 29 minus 29. So we have now in here application of the completing of the square. How do we complete the square? Again, get or take out the numerical coefficient of the expected middle term of the trinomial, which is 10 divided by 2, that is 5. And that raised to the second power, it will give you now 25. You added it in here, you have to add also in here. Okay, 25. Now notice that we have now an equation y plus 10y plus 25 is equated to 4x minus 4. Okay, minus 4. Now, what is the next? Meaning to say, you put this one, convert this one into its binomial square. A binomial square. So what are the factors of this one? That is y plus 5 multiplied by y plus 5. Next, what about this one? They have a common factor, 4 multiplied by x minus 1. Minus 1. And so, you notice, having said that one, we can put now this one into its form. Okay? We follow this form. So that is the same as saying, According now to your exponential laws, that must be what? Y plus 5 is raised to the second power. Now we have now an equation y plus 5 raised to the second power plus is equal to 4x minus 1. Notice that this one is already the what? Standard form. Okay? Standard form. Okay? We will be sketching them. So what is the very number one that we're going to get? The vertex, the focus, the value of P. We already know that the parabola is horizontal parabola. So where is the opening? To the right, to the left? To the right. Why? That is positive. That is the reason why I included this one for you to cipher kung asan doon ang equation or standard equation that you will be using. Okay? Notice that when we sketch, the very first thing that we consider are the following: the opening, the vertex, the focus, the value of P. Right? Okay. So meaning, we have now in here the equation, and thus, we can create now or we can determine now our vertex. Our vertex is the same as H and K. And so, our vertex now, as according to this one, the vertex is what? 1 and negative 5. 1 and negative 5. So that is the vertex. Can we have the focus? No. You cannot have immediately the focus. Why? You need to compute for the value of P. What is the value of P? Remember that our latus rectum as a measure of 4P. And where is that latus rectum? We have in here. Okay? And so what are we going to compute? The value of P. Now what is that? What is that? We now equate your 4P to what? To 4. And so your P now, is what? 1. Okay? So that is the P. Now can you locate now the focus? Yes, we can now locate the focus. Okay? The main fact that we know now the location of our vertex. Okay? We know now the location of our vertex. Okay? So meaning, before we locate that one, I think we have to plot them. Now that is our x-axis. X-axis. Okay? This will be our y-axis. Now, the reason why we immediately have this one is for us immediately to locate the vertex. Okay? To locate the vertex. You follow? So, meaning, our vertex now is 1 and negative 5. So, the location is in here. So, again, our vertex is 1 and negative 5. 1 and negative 5. So, that is our vertex. Now, what is the use of this one? Upon locating the vertex, you can now locate the focus using this one. Where? To the right. Why to the right? It is because this is positive. So that is 1 unit to the right from your vertex, meaning to say, we have in here. Okay? Yan. Now, when we sketch, we have to consider again the endpoints. Endpoints of what? The latus rectum. What is our latus rectum? That is the same as 4. So our latus rectum in here, our latus rectum is 4 units. Half of it is what? 2. So if that is the case, we have now 2. That is our basis in counting upward and downward from focus. So that is 1, that is 2. So meaning, our one of our endpoint is located in here. Another point that is located in here. 2 units below the vertex. Now, having said that one, you can now immediately locate the directrix. Why? The directrix is, we have now the focus. So, the opposite of that one is, we have in here. Now, it will follow, what? It will follow the y-axis. Let's try to draw. Where is that? Draw natin. Yeah? So, that is our parabola. Okay, that is our parabola. Now, what is the name of this endpoint? That is point 2 and negative 3. How about this one? 2 and negative 7. How about our directrix? So this one? Our directrix is what? X is equal to? Okay. That is 0. Okay. So meaning to say, we have now in here, we have now the graph. After plotting them, that's the time we connect now the latus rectum. That's the time we connect now the any point going to the directrix. Okay? Okay? So this one. What did we say about the directrix and the half of the latus rectum? They are always equal to this one. This side must be equal also to this one. Now, remember my symbol. When we make use of the symbol, meaning to say all those segments that has this symbol are all equal. So that is how we do the problem.